Uh, Hello everybody, welcome to this video training. Today I'm going to talk about IPv6. IPv6 is a protocol used to give IP address to the network devices. And IPv6 protocol is designed to replace the IPv4 protocol. So you may ask the question why we want to replace IPv4. There are many answers to this question. I will try to give you a few answers. First of all, we don't have enough IPv4 addresses. There are applications that don't do well with IPv4 because the use of network address translation. So you have to know that. Before we take a look at the IPv6 protocol or the IPv6 address format, we have to understand the binary conversion to hexadecimal. You know, with IPv4 we don't use the hexadecimal, but with IPv6 you need to familiarize yourself with the hexadecimal numbers and how to convert them into binary. So that's why I am giving you this table that I want you to memorize, because it's going to help you working with IPv6 addresses. But with hexadecimal we have 16 digits, 0 through 15. And in order to represent the hexadecimal digit from 10 to 15, we use letters as you see up here. An IPv6 address is a 128-bit binary number represented by 32 hexadecimal digits, and those 32 hexadecimal digits are divided into 8 groups, and each group represents 4 hexadecimal decimal number. So those groups are separated by a colon, as you see up here in this presentation, in this example. And the IPv6 address is divided into two. I mean, the first 64-bit is the network portion, and the last 64-bit is the host portion, or usually they call it the interface ID. So this is going to be very simple, because unlike IPv4, the address is going to be always divided into two parts. The network portion is going to be 60, which is the interface ID, is going to be 64-bit, and the host portion is going to be 64-bit. So as you see up here, because I'm going to talk about the interface ID later on. So you may ask the question, how are we going to be doing subnetting in IPv6, in the IPv6 world? Subnetting is going to be easy, because we're going to be getting IP address, because the host in IPv6, the devices will get public IP address, or I can say internet address, unlike IPv4, where usually the host on the LAN don't get public IP addresses. But in IPv6, the host will get public IP address. So the ISP is going to give you a /48, and that /48, you're going to have 16-bit left on the network portion, and those 16-bit will be used in order to do subnetting. So like you see up here, the ISP may give an organization the block address, like up here 2001, quadruple A, quadruple D, and a /48. And the last 6 digits in the network portion can be used by the organization in order to do subnetting. So now let's see how the interface is generated. Interface ID is generated by the devices, or is configured by the devices. The interface ID can be configured using two methods, as you see in this presentation. The first method is what we call the EUI64 method. And in this method, the devices use its MAC address as the interface ID. But the problem up here is the MAC address is only 48-bit. And this interface ID has to be 64-bit. So in order to resolve this problem, the devices insert FFFE in the middle of the MAC address, as you see up here in this presentation. So that's how the interface ID is generated using the EUI64, and the seventh bit from the seventh bit is changed from 0 to 1, like you see up here. The MAC address for this device is 00, and as you see up here, we have 02. The seventh bit represent the universal, or is called the universal unique bit. And usually a built-in MAC address for a device always have the seventh bit set to 0. So what you're going to need to do is to turn this seventh bit. You're going to change it from 0 to 1. So that's how you can configure the interface ID using the EUI64 method. So with the privacy method, the device just generate a random hexadecimal number of 64 bit. So the privacy method, and usually a lot of people like this privacy method because the reason why people are getting scared about the EUI64 is an attacker can know the device you are using based on the interface ID. So you have to keep that in mind. That's some people are preferring the privacy method to the EUI64 method. The IPv6 address is too long. So in order to reduce the length of this address, people have put in place two rules. The first rule is to eliminate the leading 0. Like anywhere you have leading 0 in this address, you can eliminate the leading 0. Like if you see up here, I have 0 db8, the 0 is a leading 0, so we can eliminate that 0. So the second rule is to replace the consecutive group of 0. Like you see up here, I have two group of two group of 0 up here, and I have one group of 0. Like you see up here, you can replace a consecutive group of 0 with double colon, but you cannot do it more than one time. Like you see up here, I have a group, this group of 0, and I have two group of 0 up here. So this rule works like that. So you can replace a group, a consecutive group of 0 with a double colon, but once only one time in an IPv6 address. So now let's take a look at the address type. With IPv6, we have three address types. We have unicast address, we have multicast address, and anycast address. So you may ask the question, where is the broadcast address type? There is no broadcast address in IPv6. So you have to keep that in mind. We only have multicast. And this multicast can be used as in broadcast too. So first of all, we're going to start with the unicast address. With unicast, we have, first of all, we have three type of address, three category of address with the unicast address. We have, first of all, what we call global unicast address. The IPv6 global unicast address is the equivalent to the IPv4 public internet address. So keep that in mind. And as you see up here, the first 48 bit is what we call the global routing prefix. It is assigned to the that's what the service provider will give you, and this is what you're going to use in order to do the subnetting in your organization. And the address start always will start with 2 or 3. So next we have the link local address. This link local address, as the name implies, is just used by the device to communicate on its on its own local area network. So those link local address are not routable, and they always start with FE80, as you see up here. And this is the interface ID, is going to be 64-bit. So finally, we have the unique local address, and those unique local address are like equivalent to the private address in IPv4. And as you see up here, they start with FD. Now we have multicast address. Just like in IPv4, multicast address are used. Multicast address are used by hosts to send messages to multiple devices. and they start with FF00. If you see those kind of address, you can say that they are multicast address. And finally, we have anycast address. This anycast address is an address assigned to multiple devices. It is a single address assigned to multiple devices. So a packet sent to the anycast address is going to be delivered to the closest device. So when I say closest devices, I mean closest in terms of routing. So the closest device is going to be determined by the routing protocol. So you have to keep that in mind. And the anycast address are allocated from the unicast addresses. So that's why I put up here no specific prefix for the anycast address. So you have to keep that in mind. So finally, let's try to see how we can assign IPv6 address to a devices. So in order to do that, we're going to go to Cisco Packet Tracer right now. Okay, as you see up here, I have a PC, a switch, and a router. But my focus is going to be the switch, the PC, and the router. And the network I'm going to be using is going to be up here, like you see up here. Network prefix is going to be 2001:db8::/64, and I put that in. This is when I use the rule, and this is when I didn't use the rules. So now let's go back to the presentation. Up here I put up here the global unicast address can be assigned using slacks, and I told you link local address is automatically assigned to the device, and the device must have that address in order to use the network. So let's go to Cisco Packet Tracer. So this PC, if I go to IP configuration up here, you see it already has the link local address. It starts with FAD, and this is what I told you. This is the interface ID, and you see the FFE in the middle of the MAC address. And if I go up here, let me put the mouse up here. So you see the PC is MAC address is 000C CF82 0E10. That's the MAC address. So if you go back up here to the PC, so we know that this PC is using the EUI64 method in order to get its own interface ID. So, but on the router side, this router, in order to get a link local IP address, you have to go to the global configuration mode. Enable conft and the interface I'm going to be that is connected to this network up here. It is the interface FA0/1. Interface FA01 is what connects the router to the network. Now, first of all, I'm going to try to do, in order to have the link local IPv6 address, you need this command IPv6 enable. That's the command you need. IPv6 enable. The command you need is show IPv6 interface F0/1. That's what you need. So once you do that, you see this router now has a link local address. You see, this is the link local address for the router, and even this router is using the EUI64 method in order to get its own interface ID. Once you enable IPv6 on the interface, the router will get its own link local address. So that's what I was trying to explain to you. So now I'm going to try to assign a global unicast address to this interface up here. And in order to do that, what we're going to do is we're going to go to the interface, because I already have the network prefix I'm going to be using, and the router is going to take this IPv6 address. So the IP address for the router on this interface is going to be 2001:db8::1. So let's go to the interface. I'm going to configure it right now. I'm going to do the configuration is IPv6 address. Let's use the question mark, and it's going to ask you the prefix. If you want, you can do the prefix and use the EUI64. If you want, you can do it manually. So in this case, I'm doing it manually, but if you want, you can do you can just give the prefix to the router, and the router will use the EUI64 in order to generate its own interface ID. So I'm going to do 2001. Okay, colon DB8. I'm going to put colon 1. And let's use this question mark up here. It's going to ask you the slash. With IPv6, we're not going to be, unlike IPv4, we're not going to be like putting a long network mask. We're going to use the slash notation. So we're going to do slash 64. And let's use the question mark. And it's going to ask you if you want to configure this IP address as an anycast or using EUI64. We don't need all of those things. We don't need any of those things. So we're going to just press enter. And now this router has, this interface has an IPv6 address up here. So how about this PC? This PC, this PC can get IP address using what we call SLAC. SLAC stands for stateless auto configuration address. So let's go to the presentation. I'm going to show you the SLACs, how it works. Like you see up here, SLACs. With SLACs, the router, the device is send what we call router solicitation message. If the router is, if the device is configured with SLAC, it's going to send a router solicitation message to the router, and the router will respond with what we call router advertisement message. And this router advertisement message is going to contain the prefix. So in order to prove you all these things, let me go back to Cisco Packet Tracer. I'm going to show you how it works, so you can have a good understanding about this SLAC configuration. So I'm going to go to this PC up here. As you see up here, it's going to ask you for IPv6. You can use DHCP, but this I'm going to talk about this for my next video coming. So I'm going to start. You can do a static configuration if you want to, but in this case, I'm going to do auto configuration. I'm going to do auto configuration. So, and you see it fails, but let me go to simulation mode. I'm gonna try to filter the packet up here, so you can understand how this IPv6 works. So I'm gonna do IPv6, ICMP, IPv6. So I'm gonna try to go back to autoconfig. So you see, this guy is sending what we call, this message is what we call a router solicitation message. Let's open it. As you see up here, it say router solicitation message, yeah, like you see up here. And this router solicitation is asking for the prefix. And guess what this guy is using as a source IP address? That's its local link address. And the destination IP, this is a multicast address, because it starts with FF up here. So let's forward the packet. This packet, the router will receive this packet, and this router is going to respond. Guess what? This router should respond with router advertisement message. But the reason why it didn't happen, because we forgot to do one configuration on the router. It is let's go back to the router. I'm gonna stop the simulation. Let's go back to the router. This is the command I forgot to put. It is called IPv6 unicast routing. So you have to put this in order to make this router capable of sending a router advertisement. If you don't do that, this router will not be able to send a router advertisement. So let's go back up here. I'm going to go back to simulation. I'm going to go back to the simulation up here. I'm going to try to go back to the PC up here. So go to start. Just do the static checkbox and go back to autoconfig. So now let's try to send the packet, this route solicitation message So now the router is going to respond. You see the router is responding, and let's open up this packet. And if you open up this packet, you're going to see that this router advertisement, let's open it. I'm going to show you something. It contains the prefix. You see the prefix. Very important. You see the prefix. That's all I'm looking for right now. And the router is using also its own local link address. Like what I told you, for communication inside the network, always the device will use their own their link local address. So as you see up here, and now, so let's stop the simulation. And now finally, this PC is gonna get its own its global unicast address by using the interface ID up here and with the prefix. So as you see up here, so that's how the PC will get its own IP address. So I hope you guys understand this process. So I'm gonna thank you for watching this video, and I see you for my next one.